Hello, my name is Alexander Assal, and this is my Honors Algebra 2 polynomial final. For my base equation, I got 4x to the 5th plus x to the 4th plus 6x to the 3rd plus 2x to the 2nd plus 5. This is because my birthday is on April 16th, 2005, and that is how I derived the equation. My graph, the original graph, is on the yellow line, and the blue graph is the more interesting one, which I put a negative number into, and I'm going to be doing both graphs for this final. The degree for my polynomial is 5. We can determine this because the highest exponent in the polynomial is 5. And this is the graph of both of them. For the domain and range, we can determine that both the domain and range are negative infinity to infinity for both graphs. For the next section, we're going to be covering the y-intercept. For the y-intercept, we can see that on both of these two equations, that they both line up on 5. Now, this is how we have determined the y-intercept. Alright, so here we have the x-intercept. In the first image, we could see that the graph is showing the x-intercept for the original birthday problem, okay? And that is negative 0.924, 0. And in the second image, we could see that it is the birthday graph that looks more interesting. And we can see that the x-intercept for this is negative 1.5890. Very cool. Alrighty, now that we've done the x-intercept, we can now move on to the minimum and maximum. For the original birthday graph, we can see that the minimum is 0.687, and then the y is 4.833. And the maximum value is negative 1.142, and the y is 10.476. We can see this in the picture on the graph, on the top one, the blue one. And the changed birthday graph's minimum is 0.5, and the maximum is negative 0.2211 to 5.033. We can see this displayed on the red graph on the bottom. Alrighty, now we're going to look at the 5 tested points for each graph. I tested 5 points on each graph. On the first graph, you could see all the different points that I chose, and on the second graph, all the points that I chose. When I plugged this into the equation, they all came out working perfectly fine, which proves that I did this graphing correctly and everything was okay. The next thing we're going to take a look at is the end behavior. And the end behavior is how it starts and how it ends. Now we're going to see that I found this graph from the Algebra 2 textbook, and the end behavior for the first graph is up and up, and it is the same thing for the second graph since they have pretty much the same equation, which is up and up. We could see this from the chart on the right. Now we have 3 more graphs. These 3 graphs I got from using the same equation, except I changed the sign in the equation, and I thought they looked pretty interesting, especially the white one, where it kind of just curved a little bit instead of a lot like the other 2, and I thought that was very interesting. Thank you for watching my presentation on the Algebra 2 final.